Good afternoon. Hope you had a good lunch and everybody's ready for a few more sessions. The next 3 sessions will all be in here. Our next speaker is invited speaker, Kimon Onuma. His name up there. Kimon is an architect from Pasadena, California. He's been a passionate evangelist, supporter, participant in something called Building Information Model, or BIM. And he's going to talk to us today about BIMstorm, which is, I guess, a kind of pun on a brainstorm. And this addresses a lot of these issues about information collaboration. So Onuma Inc. is both an architectural firm and a software company. I went down to Pasadena to see a BIMstorm, so we could bring one here. And so I now give you Kimon Onuma for BIMstorm Vancouver.
Thanks, Ron. And thanks, everybody, for having me here. I'm very excited to be here because I think collectively we have the answer to the problems of the world, a lot of the problems in the world today, including global warming. If we can figure how to harness the power that we have in this room, there's really a solution there. I'd like to start with a short animation, and I'll do some talking in the background here as we go through this. This is actually a project that we received several awards on. I'm going to be talking about building information modeling, and there's a concept of little BIM, which is just a piece of software or the project that you're working on, and the concept of big BIM, which expands it beyond just the project and looks at the data and looks at the process of how things can change. And this is a project that we actually worked on with the US Coast Guard, looking at open standards and looking beyond the envelope of the building and even how it ties to the whole enterprise and the portfolio of the Coast Guard. All organizations have a problem of how to manage their existing infrastructure and also to plan for the future. How do we predict what we need when it's a constantly moving target and when there's constantly increasing amounts of challenges we're faced with as far as the technology, the requirements, the budget, the world, everything. So this was a pilot project for 35 command centers, which we went through and used the BIMstorm process on. And I'll be going to the BIMstorm in a few minutes here, using web-enabled tools and real-time planning to collaborate worldwide with many users from many different perspectives. It's not only about the building, it's also about their business needs and drivers and data associated with buildings and spaces and sites and things inside buildings and how they operate and how they manage and support the Coast Guard's needs. This is a command center in an existing building. Do we put it in an existing building? Do we build it in a new building? Do we expand and lease space? How do we manage our entire portfolio of existing buildings and tie that to our business process? So it was a very exciting series of projects with the US Coast Guard that our team, along with several other teams, worked on. Looking at the building as a database, looking at, from a geospatial perspective of needing to land buildings somewhere in the world and being able to do scenario planning on the entire Coast Guard inventory, which you're seeing up there right now, is what we call low level of detail. They're blobs, just blocks, but some of them also have higher levels of detail. And then tying it to their business drivers, which are their ships, their cutters. Doing a supply and demand, knowing your supply of buildings, you can start simulating what-if scenarios, what happens if I plan and that ship drives the need for a building. So it was a decision engine to simulate really quickly different scenarios. And it was tied to a lot of other things too. It wasn't just the buildings, there was people, there's a lot of pieces to this. So let's cut this off for a second, and what I'm going to do is I'm going to make a quick phone call here. See if Thomas is online. Give him an assignment. Thomas, let's see if he's going to answer. I'm going to give him, what we're going to do is go through what we call the BIMstorm process, and we're going to do it for Vancouver. This started actually the other day. In fact, it started several weeks ago when we were prepping for this. Thomas, you're online?
Yes, I am.
Hello, Thomas.
Hi, Kimon.
I'm just give you a quick assignment. We landed a laboratory in Vancouver, and I'd like you to do a design study on it and see what we can do with the project. And we'll come back to you in about 30 minutes. Is that okay?
Okay, I will.
It's the one that's called Laboratory, and the Building Smart Alliance, actually. This project, actually, we have a presentation going on at the National Academies right now, yesterday and today, which we designed a laboratory, and we're going to take that laboratory and move it from Washington, D.C. to Vancouver. Okay, so let's start with a PowerPoint and then get back to some of the live stuff. So I want to start off with this concept. Buildings are not static. They change like the weather. This might be kind of an unusual concept, but it's very true. Look at this building we're standing in. There used to be a front door there, and now they changed it into a different configuration. So what does that really mean? It means that although we think buildings are relatively static, there's constant change inside a building, whether there's a renovation going on, or whether there's an event like this, or whether there's a demand for electricity, or things moving in and out of the building. So it's not a static concept. It changes daily. And in fact, with the Coast Guard, as we were going through and documenting their existing buildings in a campus, 30 buildings, there was teams coming in from the backside doing renovations to the ones that we had just measured. So it's a constant change. How do we track that change? Because as soon as something is no longer current, then it's obviously a problem with the whole database of how do you manage your information if it's constantly changing. Another concept I show a lot of is the concept of Expedia, or any kind of airline reservation system. You're given an interface to make a reservation, but you're not allowed to reserve the pilot's seat. Yet it's all integrated together and you get a real-time bid. You don't download an Excel file and come back to Expedia and try to make a reservation from a 2-week-old data. Also, if you imagine this system, and if we did not have the internet or reservation systems like this, and we had to go out and collect all the airlines' reservation from paper documents and create a database, it would be doable. But then who manages all the different airlines' data? It's really the airlines that manage their schedules, and they give us an interface to make reservations. So it's really who's the owner of that data, and how do we manage it? And the concept of dynamic buildings actually relates to that too. How do we manage buildings that are constantly changing? So building information modeling, BIM, can be complex. It's very powerful. There's a lot of, this is actually some case studies. This is from Ghaffari Associates, the General Motors plant, going down to the nuts and bolts and the structural and mechanical systems, simulating them before any construction happens. And in this way, buildings are dynamic too, because before any construction starts, there's a lot of iterations of what if we put this kind of mechanical system, what if we expand the size of the square footage? It's constantly shifting. There's also this example from the Denver Art Museum, Daniel Libeskind, looking at construction detail. So it can get very, very complex and detailed, and it's an important tool because if you can simulate this complexity before you start construction, it saves a lot of time and money. BIM can also be simple, and I know a lot of you are connected here, and I'd like to try this exercise. If you don't mind, and it's also on your sheet of paper, log into, this is a 2-minute exercise, bimstorm.com/mobile. We're all going to create a BIM, basically, by the end of the session. Let's go ahead and log in to bimstorm.com/mobile. And let me do that too myself here. It actually works from an iPhone too, but you can just use a regular browser. It's we call this BIM on demand. And there's 3 pieces of information that we need to enter here. First, choose the user group, and let's choose BIMstorm Vancouver. And the password, BIMstorm Vancouver, and the password is BIMstorm31, no space. And at the top, there's 3 pieces of information. I want to put it's a project name, but put your own name so we can identify your project later on. So I'm going to put my name here. This particular interface is only in square feet. We have a metric one too, but let's just focus on the square footage one. It's the total square footage of the building that you want to put together. So if it's a hotel, it might be 120,000 square feet, say, for a big hotel. Put 120,000, or put any number you'd want there. You don't have to follow what I'm saying. And put the number of floors. I'm going to put 16 floors for mine. And then you hit upload. That's the beginning of a BIM. That data now is sent to the BIMstorm process that I'm going to show live later, and it's actually created the first building. If anybody has any problems or doesn't remember the password, it's actually on the sheet that was passed around, number 1 on the sheet. You can keep on building buildings as I'm talking if you'd like. And what Thomas is going to be doing in Hawaii, he's one of my team members in Hawaii, he's going to take your buildings and actually move them into Vancouver, and we're going to look at that result later.